In this video, we'll use ArcPro's Model Builder to visualize and run our den suitability model. In the catalog pane, navigate to the Wolverine toolbox in the Lab Data folder. Open the toolbox by right-clicking it and click Edit. A new window will appear, and this is called the Model Builder window, where we can automate multiple processes and retrieve a final output given our parameters. With a GIS model, we can do analysis that takes into account more than one or two layers and more than one tool. We can also share that model with others so they can follow the same steps. In this case, the PhD student you're working for has given you the model, so we first need to make sure that everything is linked properly. Take a look at the different layers and tools in the model. Blue circles represent current layers, yellow squares represent tools, and green circles represent output layers. Since the model file came from our PhD student, we have to change a few things in each tool and process. Double-click on each layer to make sure that the input layer matches your layers in the project. We have a few parameters for our model, and we'll go through each one. Researchers have determined that wolverines often inhabit areas where a slope grade is less than 40%. So first, we're doing a raster calculator on our slope raster. Make sure that the output raster is going into your project geodatabase and title it the same as the respective output name in the green circle. Next, we know that wolverines are likely to den on north-facing slopes where the snowpack is greatest during the winter. So we can use the Reclassify tool to select all of the north-facing slopes and reclass them as a 1, where everything that doesn't meet this criteria, we reclass it as a 0. We also already figured out that the wolverines prefer elevations above 7,875 feet. This will give us a binary raster just like the one we created before. But make sure that the output name matches the name in the green circle for the output for this process. Lastly, since we want to find areas where these three parameters meet, we will multiply the three output rasters together to create our final den suitability output raster. Once all of the output file paths are corrected, you can then click Run. After a little bit of time passing, you should see 4 new layers appear in your drawing order, including your final den suitability output raster. If you get any errors, it could be that the file paths haven't been changed properly. Notice that the new layer is a binary map as well, with only 2 colors, where 0 doesn't meet our criteria and 1 does meet our den suitability criteria. We can change the 0 value color to no color in the symbology pane, so that way we're only viewing areas that meet the den suitability criteria. Open the attribute table for both your viewshed and your viewpoint layer, and try to make a case for why you might now choose one of the viewpoints over the other based on the viewshed and the den suitability raster. Remember that the value field for the viewshed raster corresponds with the object ID field in the viewpoint vector data. In the next video, we'll actually calculate which viewshed has the most amount of viewable den habitat area within it.